Okay, so you've probably watched the previous part of my video. I'm going to be continuing on now to deduce the second phase of distance. So let's have a look. And the formula of motion that I reckon would work would be S equals VI t plus half AT squared. Now, don't get confused with the original VI, because we're looking at just the second segment. If you remember the acceleration phase from the last video, the VI of that was 0. Well, here, the VI, because we're looking at the second section, just this section here, is going to be 15 meters per second, as deduced from the last video, and the acceleration is going to be 0, so that's also going to be just the average velocity. So we can write this as being VI now, just for the second segment, and we can calculate away. So the VI is 15, and the time we're looking at is 135 seconds, and then we're looking at half of 0, because remember we're not accelerating, and then time squared, which is 135 squared. It's just a matter of simple substitution from the values I calculated at the end of the last video for the second section of rail. Now look here, half times 0 times 135 squared is obviously going to be 0 because there's a times operand of 0 in there. So basically, when you multiply anything by 0, it's going to be 0. So if we were to do this, half 0 is 0, and 135 times 0 is 0. So goodbye to that section. That's only if we're accelerating, which we're not. So what we can do now is we can just focus on this value here. 15 meters per second for 135 seconds. And from this, we can just use our calculators to be able to deduce it, or derive it. And we get 2,025 meters as being our S value. And of course, because these are all SI units, as you can see, meters per second, seconds, meters per second squared, it's basically just going to be in meters, because that is the SI unit. So now we have deduced the second phase, and we can add it to our little tally here, 2,025 meters. So now we just need to look at the third and final phase, which is the retardation phase, where acceleration uniformly retards for 10 seconds. So this is where things get a teeny bit tricky, but hopefully they shouldn't be too bad. So, well, what do we know? Well, we know that the initial velocity of the third phase is still going to be that 15 meters per second. And we know that the acceleration is going to be negative something because we're deaccelerating. And what we lastly know is we know that, well, x is obviously going to be something that we're going to need to calculate, and we're also going to need to know what we can calculate in terms of, well, we obviously know time is 10 seconds as well. So using this kind of logic, we need to work out what formula is best to use, and we can add another thing, which is velocity final being 0 meters per second, because of course we're coming to rest. So I reckon the formula that's best for this is velocity final take velocity initial equals 2as. And to be able to use this, we basically just substitute in the values. So that should be an equals there, just so we don't get confused. So we have 0 being our last bit, 0 squared, take 15 squared. You can see I just plugged in the values. And we have 2 lots of the acceleration, which we don't know, over the distance, which we also don't know as of yet. So that is what we ideally want to be able to get. However, until we can get that, we're going to need to look at another formula for calculating it, because we have 2 unknown variables. So this other formula we can look at can be looking at getting distance, for example, and we can use the initial velocity, 15 meters per second, and time, and then we can also look at just calculating, obviously, what the acceleration would be as well. So we have two different ways of calculating the last bit, but we need to be able to get one value first. So as you can see here, I'm just showing you basically that there are multiple ways to be able to calculate it. But for acceleration, it's really easy to get. We use the final velocity, take the initial velocity, like usual, over time. So the velocity final is 0, negative 15, and over time, which is, of course, going to be 10 seconds. So therefore, we get an acceleration of negative 15 over 10, which equals negative 1.5 meters per second squared. So now we can use either one of these formulae to be able to plug in the answer. So I reckon I will probably use velocity final squared, take velocity initial squared, just because that has less variables. But if you don't want to get confused with all the square rooting and all the mathematical operations, and this is probably quite easy to do to be able to get the distance. With this one you have to make S the subject of the formula, which I'll probably show you because it's a bit more difficult, but again, feel free to use this one if you're interested. Again, as I've shown it in the last video a few times, so you should be able to pick up on what it is. So, I'll use this formula, and I'll just plug in the results I've got. Final velocity is 0, initial velocity is 15 squared, because obviously you're going to have to square it there. Then we have two lots of negative 1.5, and then we have S, and S is unknown. So, we can get rid of that, and that's just negative 15 squared. And that equals two lots of 1.5 S. So what we can do next is we can go negative 15 squared. In fact, what we'll probably do is we'll probably go and actually expand negative 15 squared first. And basically from that we're able to get negative 225. And we'll bring the 2 down there because we're able to just bring it to the next side by inversing the operation. Again, if it's in the numerator, then we move it down into the denominator. So we get negative, and we can just use our calculator to be able to deduce this again. 225 divided by 2 is 112.5. So we basically have on this side 112.5, and I'll just rewrite it out here. 112.5 equals 1.5 lots of S, and that's also negative there, of course. So now we just move this onto the other side as well, because of course negative 1.5, move it to the other side, it'll become positive 1.5. However, what I should note here is when we did square this, this actually becomes a positive, because negative 15 times negative 15 equals 225. Sorry, I just forgot about that for a second there. But negative 15 times negative 15 is positive 225, because a negative times a negative is a positive. Sorry to get confusing there, but the negatives and positives always get to me. So we have 112.5, and when we bring this to the other side, it becomes positive in the denominator, so we've got 1.5, and we're able to calculate what S is based on that. So again, we can use our calculator. 112.5 divided by, and then we have 1.5 in the denominator there. So we get from that 75. S equals 75 meters for the third phase. So now it's just a matter of adding it all up. So we had 225 plus 2025 plus the 75 that we just calculated. So as we can see here, 75 plus 225 is going to be 300, and then we have 300 plus 3025, and we're able to get 3,325. However, when we look at our significant figures, our first given value was basically only 2 significant figures. So we can only write this as being 3.3 times 10 to the 2 meters. Sorry to cut it short, but that's basically what we do here.